Okay, so this is the last week of CP2 in terms of covering topics. So this lecture will talk about the shortest path in graphs. So there are many variations of shortest path in graph. So first, depending on the problem, maybe they ask for shortest path from a single point. So this is called a single source. Or the shortest path between any possible pair. So this is called all pair shortest path. So you need to use the different algorithms. Sometimes some algorithm can be used for solve both kind of problem. But depending on the property of the graph and the kind of the problem, you may want to choose one algorithm versus the other. So single source, it's equivalent to single destination, and all pairs can also be solved by solving single source for every node, choosing every node as the source. And it also depends on what kind of graph are we looking at. So if the edges are unweighted, so that means every edge has the same weight. So for example, every edge has weight 1. Then that problem we actually already encountered before. So that is solved using a breadth first search. So for example, if we are looking for shortest, fewest number jumps to go from the beginning to the end, so we solve that using BFS, using a queue. And the Dijkstra algorithm is actually fairly similar to that algorithm. If the graph has, if the edges have weights, and the weights are non-negative, then we can use algorithms such as Dijkstra and Floyd-Warsaw. And some algorithm can handle weighted graph where the edges are negative weight, so long as there are no negative cycles. And if you have a graph where there may be negative cycles, then the only algorithm that can be used is Bellman-Ford. So there are three basic algorithms. We'll cover all of them: Dijkstra, Bellman-Ford, and Floyd-Warsaw.